My name is still Jamie Franzese. I'm an international studies senior from Edmond, Oklahoma. And this semester I've had the privilege of working with the technology commercialization team as a team leader. This semester we've been tasked with commercializing an insanely complicated fluid analyzer in the oil and gas space, but I'll let the team explain our recommendations and the insights there. But before I welcome them to the stage, I do want to thank a few people who have made this project so successful and so it's such a pleasure to work on. So first, thanks to I-CCEW staff, Jeff, Sue, Cass, Susan, Patrick, Michael, and our fellow Joe. Thank you so much for not only investing in the project, but investing in the students as well. You guys make it enjoyable to come to the office, but your framework has also made it possible for us to solve these problems. So thank you very much. In addition, I want to thank our mentor, Dr. Rai, and our inventors, George and Mark. You guys have been such a pleasure to work with, fielding our insane amount of questions about things that you probably think are for elementary schoolers, but you've really made this project so enjoyable to work on. But finally, I want to thank the 4 interns that have made this project not only so fun, but just such a challenge every time I come into the office. You guys made it worth coming into the office at 7 a.m. on multiple occasions. You made it worth staying much later than my bedtime. You don't really know what to expect whenever you work with 4 insanely interdisciplinary individuals, but I learned some weird stuff about my interns. So, for example, I know that Rama's favorite sandwich is pretty much just like bread and boiled eggs, which I just think is like super strange. Also, Soham doesn't believe in ghosts, which he's wrong about, but also he's really, really good at bowling. So don't ever, he'll hustle you in that. So I learned the hard way. Also, Morgan's pump-up song, or not Morgan's pump, I'm sorry. Morgan is actually a bodybuilder, and you would never guess that, but she could probably lift a truck. And finally, Liz, her pump-up song is actually on the Michael Bublé Christmas album. So, baby, it's cold outside. She gets crazy. Anyways, so now please welcome to the stage Morgan, Rama, Liz, and Soham.
Thank you, Jamie. HydroVirga is a fluid analysis system that has garnered over $130,000 in funding through accelerator programs and has received a patent from the Department of Energy. The previous I-CCEW team went out to the Bay Area in California, where HydroVirga is located, and found many applications for the device, ranging from paper production to water supply testing to fluid analysis in the oil and gas industry. We were tasked with commercializing HydroVirga in the oil and gas industry. Through our interviews with refinery managers, refinery superintendents, chemists, process engineers, and fluid analysis service providers, we have identified a $64 million market opportunity for HydroVirga in fluid analysis in oil and gas refineries. We evaluated HydroVirga against 4 industry-leading competitors and have found that HydroVirga is 98% faster than competing technologies, requires less than half the maintenance compared to current fluid analysis technologies, and effectively eliminates the margin for error in interpretation of fluid tests. We have constructed a business model for HydroVirga that will generate $4.3 million in revenue in only 5 years. I'm Morgan Nash, an economics, philosophy, and religious studies senior from Tulsa, Oklahoma.
I'm Elizabeth Greer, a management information systems and communications senior from Fort Smith, Arkansas.
I'm Rama Osman. I'm a biology major senior from the Netherlands.
I'm Soham Pandya, a PhD candidate in petroleum engineering, and I'm from India.
And together with our inventors, George Farquhar and Mark Stevenson, our mentor, Dr. Chandra Rai, our fellow, Joe Chirunji, and our team lead, Jamie Franzese, we are Team HydroVirga. Oil and gas powers the Oklahoman economy. It's necessary to first understand what role fluid analysis plays in the oil and gas industry so that we can know how a fluid analysis device like HydroVirga can ensure that oil and gas meets quality standards before going on to the market. Oil and gas is first stored in a distillation tower, and it's then flowed through reforming units, and it then becomes the end product of kerosene, diesel, jet fuel, or any other type of fuel that needs to go through the refinement process. There's a fluid analysis device placed before each reforming unit to ensure that the crude oil and natural gas will not damage the reformer. And there's also a fluid analysis device placed after each reforming unit to ensure that the reforming process was successful and the product is safe to go out on the market. This process occurs at multiple points throughout all 141 oil and gas refineries in the United States. This indicates that refineries need multiple fluid analysis devices. The exact number of fluid analysis devices depends on how much oil and gas a refinery produces in a single day. Our interviews with refinery managers at Holly Frontier and Big West Oil have indicated that smaller refineries need, on average, 10 fluid analysis devices, whereas very large refineries that produce hundreds of thousands of barrels of oil in a given day can need up to 70 fluid analysis devices. Now that we know about the industry that HydroVirga is entering into and what role fluid analysis plays, here's Liz to talk about the technology itself and the problems that it can solve that refineries are currently facing.
Thank you, Morgan. Petroleum engineering professors, researchers, and PhD candidates on the OU campus helped us to better understand HydroVirga as a technology and confirmed an industry need for this type of fluid analyzer within refineries. HydroVirga serves as a lightweight, portable fluid analysis device that is no larger than the size of a briefcase and requires no more energy to power than that of your laptop computer. HydroVirga utilizes NMR, or nuclear magnetic resonance technology, meaning that it uses magnets to analyze the chemical composition of petroleum fluids to help ensure that all of the industry safety standards are met based on the American Petroleum Institute standards. Upon a fluid test, the results will display on a screen and an easy-to-read % concentration output. A unique feature of HydroVirga is that this output can be easily manipulated to meet a refinery's exact specifications. For example, if additional analytes need to be accounted for in the sample, a refinery expert will simply attach a new probe to the end of the device. Another unique feature of HydroVirga is that the algorithm on the device can be altered remotely in real time. In all, HydroVirga helps lab experts to better visualize what the chemical composition is of a fluid and ensures that all lab specifications and government regulations are met before the petroleum products can be sold to wholesalers of various industries. While there are current testing practices in place, HydroVirga offers a unique, advantageous value that is lacking from current devices. In total, HydroVirga can save a refinery over $700,000 and over 360 labor hours in a given year by offering superior efficiency, less maintenance, and easier interpretability and a much lower cost than competing devices. A current device can take numerous hours to conduct a single fluid sample. However, HydroVirga takes just 2 minutes, making it 98% faster than the industry average. Current devices can also cost a refinery over $50,000 a year in maintaining the supplemental parts to run the device, and they must be manually calibrated by the lab technician operating them. However, HydroVirga does not require any additional parts to run, and the device automatically self-calibrates after every time it is powered on. Current devices produce test results in a confusing graphical output. According to Michael Swanson of Big West Oil, the miscommunication and misinterpretation of these graphs can lead to hundreds of different errors within the samples, equating to over $500,000 lost per refinery per year. HydroVirga has a less than 1% failure rate and yet still provides its test results in an easy-to-read % concentration output. Lastly, current devices can cost a refinery $25,000, yet still require part replacement every 6 months. HydroVirga is valued at $15,000 less, meaning the device costs just $10,000 to a refinery and requires no part replacement for at least 3 to 5 years. Now that we know more about HydroVirga as a technology and how HydroVirga can remedy the problems facing refineries, here's Roma to discuss HydroVirga's market opportunity and the competitors within this market.
Thank you, Liz. Currently, there are 4 competing technologies for HydroVirga, such as gas chromatographers and various other spectrometers. HydroVirga is able to detect analytes in real time. From our interviews with refineries, we have found that current devices are very time-consuming. In fact, technicians spend over 360 hours per year just waiting on results. HydroVirga will also not require a skilled chemist or technician to operate the device. This is because the output of HydroVirga will be in a simple % concentration rather than a spectrum, as is seen in many of our competitors. This can allow refineries to save over 104 hours per year in result analysis. HydroVirga will also not require frequent maintenance. In fact, it will have an automatic calibration function, which will eliminate the need for refineries to continuously calibrate the device. Finally, HydroVirga is also cloud compatible, meaning that all software updates can be performed from a remote location. Our numerous interviews with refineries and service providers have demonstrated that in order for a fluid analysis device to be successful, it should be quick, easy to read, and easy to maintain. HydroVirga is able to offer all of that and is yet estimated to be the cheapest on the market. Now let's look at the market opportunity. HydroVirga is able to enter into a $64 million on-site testing market. This market is composed of two segments, lab testing devices as well as inline testing devices. Lab testing devices equate for $13 million or 10% of the market. However, we will specifically focus on inline testing devices. This is because of HydroVirga's technological design, a portable, real-time fluid analyzer which can have a significant effect on the oil and gas industry. Our interviews with service providers like Gentech and Intertek have demonstrated that on average, refineries use 30 inline devices. Since each device is valued at $25,000, this gives an overall value of $106 million. Within this $106 million inline testing segment, an interview that we had with a superintendent manager at Holy Frontier Refinery, he confirmed that HydroVirga is able to conduct the same test as a gas chromatographer. This is 60% or $64 million of the inline testing segment. As HydroVirga continues to technologically develop itself, the market opportunity for HydroVirga is also expected to increase. To illustrate the applicability of HydroVirga in the US, here is a map with the distribution of refineries. As you can see, most of the refineries are concentrated in the states like Louisiana and Texas. However, some of the other refineries are represented in the Bay Area. This can especially be helpful for HydroVirga's commercialization plan, as HydroVirga is currently based in California. Now that you know a little bit more about how competitive HydroVirga is, its market opportunity, and how the refineries are distributed in the US, here is Soham to tell you more about the business aspect.
Thank you, Rama. HydroVirga clearly has a competitive edge in the market. However, in order to capture that market, HydroVirga needs a strategic business model. For this, we recommend that HydroVirga targets the states of California, Louisiana, and Texas to begin with, initially through direct sales and then through distribution network. These three states in combined comprise of 43% of the US oil and gas refineries, and that's why we have shortlisted these three states. These refineries may vary from small scale to large scale depending on their daily processing capacities. Hence, the number of inline fluid analyzers in these states may vary. To start with, HydroVirga should go into direct sales with the small scale companies or small scale refineries in California. This is because HydroVirga is a company based in California and it would be really easy for them to go into direct sales with these small scale refineries. These refineries can be used as a test market for HydroVirga, and based on the response from this test market, HydroVirga can further develop their technology in order to better adapt the remaining market. Next, HydroVirga should go through distribution channel or stocking distributors. These distributors buy the devices in bulk. Going through this route would enable HydroVirga to expand the market to the mid-size and large-size refineries in addition to the small-size refineries. The distributors that we have shortlisted for HydroVirga are JPR Systems in California, Trinova in Louisiana, and Vector Controls in Texas. The shortlisting is majorly done based on their market coverage and their technical expertise in inline fluid analyzers. In fact, through one of our interviews with the sales representatives from JPR Systems, it was quoted to us that HydroVirga would strike a jackpot if it is able to strike a deal with Vector Controls in Texas. This is majorly because Vector Controls is a result of a merger of 5 major distribution companies in Texas. Now let's look at some numbers. The current estimated manufacturing cost of HydroVirga is $5,000 US. We recommend that HydroVirga goes in direct sales with the small scale companies with a price point of $10,000 US. This will bring back a profit margin of 100% for HydroVirga. In terms of the distribution channel, since these stocking distributors will buy the devices in bulk, HydroVirga will be able to provide a reasonable discount anywhere from 15% to 30%. This will bring down the profit margin to 70%, but it will also increase the number of units sold at once. With these numbers as basis, the profit projection plan for HydroVirga indicates that it will be able to garner a cumulative of $4.3 million of profit within the first 5 years, and would be able to capture 39% of the market. One of the key success factors for HydroVirga in this model is that it would be able to double the number of units sold, also the amount of profit that it generates from year 1 to year 5. One of the key assumptions that goes behind this model is that HydroVirga would only be able to target a fraction of the refineries in the states that were mentioned earlier. This was done to make this model a conservative one. Also, another assumption that goes into this model is that HydroVirga will only focus on direct sales for 1 year, and then from year 2 to year 5, it will majorly focus on the distribution channel. Now, to make this model a success, HydroVirga still needs to go under certain technological developments. To start with, we recommend that HydroVirga looks into developing algorithms to test for sulfur content. This is because sulfur is one of the major elements that is tested for in refineries in addition to hydrocarbons. Next, HydroVirga should also start obtaining the ASTM certification. This certification states that HydroVirga meets the minimum required standards in the industry. Also, ASTM certification is one of the key factors that is considered by refineries as well as distributors before deciding on purchasing a fluid analyzer. In terms of business model, HydroVirga should start shortlisting the refineries that it wants to use as test market and hence get the name out in the market. Following which, HydroVirga should approach distributors that were listed earlier and hence create a brand expansion. All in all, the interviews that we did, the research data that we gathered, all of them suggest us strongly that HydroVirga has a potential to become a big brand in the refineries. This is because it is a cost-effective option, solves the current industry problems. In fact, it saves up to $700 for refineries. It also has a tremendous market of $64 million US, wherein it can replace the current inline fluid analyzers. Also, with a strategic business model, it can garner over $4.3 million US in profit within the first 5 years. Thank you. And now we would like to open the floor for questions.
Can you talk a little bit more about how you arrived at the pricing recommendation? It seems like HydroVirga is durable, more accurate, even can save on some post-purchase costs, while at the same time being essentially cheaper from competitors. So why is it more?
That's a great question. The question is, why have we set a price point of $10,000 US for HydroVirga, even though it can do a lot more functions than the current fluid analyzers? The main reason for that is HydroVirga is a new company which would be entering into market. Hence, to incentivize the distributors as well as the refineries, we have currently decided a price point of $10,000, which may increase later on depending on the response from the market.
When you concentrate exclusively on refineries, this technology seems actually quite amazing. Gasoline, JP4, all of these things that store in the state, I would think that you would want to test those various locations and there's alternatives, additional places. Why don't you examine those places where the same technology would be applicable?
So the question was, why did we look exclusively into refineries for HydroVirga rather than looking into other applications for HydroVirga in the oil and gas industry? We did actually explore all of these applications in the oil and gas industry, ranging from the well to the gas pump. We found that there's the greatest demand for inline devices. Additionally, HydroVirga cannot solve some of the problems going on in exploration due to the limitations of its technology. So we found both demand and a need for HydroVirga in refineries that we did not find elsewhere. It could expand later.
So the question is, what if these distributors are also selling other type of fluid, inline fluid analyzers? along with HydroVirga. Is that correct?
Yes.
So we have looked into that, although especially with TriNova and vector controls, it is difficult to weigh on that factor. But JPR Systems is one of the distributing company which has the technical expertise in inline fluid analyzers, but still it has limited number of inline fluid analyzers that it sells.
So are you saying that the distributors will realize competitively that HydroVirga is superior to the other products they're carrying?
So the answer to that is it will weigh on what the purpose of what's the problem the refinery is facing. So if HydroVirga is exactly applicable over there, that's when they'll recommend HydroVirga. If HydroVirga cannot solve that problem, they probably won't recommend the HydroVirga device.